So me and my wife just recently purchased the 3D printer off of GearBest, and I just couldn't wait to start doing some interesting things with 3D prints. So I went ahead and edited what was originally my OpenGL game engine to produce height maps and export the vertex positions to an object file. So before the video started, I went ahead and found a new height map to use named Veins. So I'll go ahead and change that. I'm not going to go into how exactly this entire program works right now because it's kind of complicated. However, I do have to currently edit most height maps to be 256 pixels by 256 pixels. So what's unique about this, however, is that it takes height maps and automatically converts them to low poly versions of the terrain that it's supposed to be mimicking. That's done over here in the shaders, while flattening the vertex positions and flattening the normal positions inside my shader is just for visual effect. If I wouldn't do that, it wouldn't appear, the lighting wouldn't work how I wanted to inside the program. So right now I've imported veins. It's going to be exporting as vein object. I wrote all this myself. Let's go ahead and take a look. The object will be fully interactable inside the program once it starts running. But it'll also export a file that we can go ahead and throw inside Slicer and export as G-code to our 3D printer, which I haven't tested yet because we don't have a 3D printer yet. So we're going to go ahead and let this boot up. It's not perfect, obviously, as most things are that you make yourself. There's a few things that I need to change. Right now, one of the biggest setbacks is the fact that we got a little vase that I was going to use as a player. Oh, I've actually never seen this model. Ooh, I kind of like it though. It's kind of big, so the low poly effect doesn't work super well. So, first, the real issue we have is, if you notice, the bottom is hollow, which is fine because this was originally a game engine, so this terrain map wasn't meant to have a bottom. But you will see if you try to import this into anything other than Slicer, it's going to have issues. It's going to have issues like understanding what type of shape it is. It'll just crash the program. But Slicer seems to do okay. It automatically just figures it out. There's a few. So we got the height map here. It looks pretty neat. But if we close this, we'll notice that it's automatically created a vein object right here. That if I go ahead and, oops, where's my desktop? There we go. Go ahead and export that to my desktop and open up Slicer. We can go ahead and, please stop doing that, put it into the Slicer program. So here we go. We got it here. So you'll notice that a lot of the fragments are kind of drawn in a weird way. So let me rotate this around the x-axis. There we go. So here's the height map created from nothing but a flat 2D PNG. It's really small right now, so let's scale it up. Scale uniformly, and 10,000. Which is okay, because I actually want these little polygon shapes. I don't think it'll really work when it prints, but it's still pretty neat. Let's see if this has some of the issues that the other ones have had. Yeah, here we go. See on this far side that these vertexes are kind of matching up with ones that are all weird and whatever. I actually know how I'm supposed to solve this. It's just a little bit more work than I'm willing to do at the moment, and it works enough for me to make a little video about it. So you'll notice that it does actually put a bottom on it, but see all these weird diagonal lines? It's because it's connecting the vertexes in weird ways and drawing really elongated fragments, which is okay for the purposes of printing one way or another. So let me scale this along the z-axis. It's going to exaggerate some of the features, but it's also going to let me cut the bottom, because another issue there is with the sides, these little extra zones, right? Sticking off the edges. I could cut off a little bit of this and make this printable, which I'm probably going to do before I go ahead and change the code a whole bunch, because in order to fix these problems, I have to completely change the way that my little engine handles creating the mesh at all. No, I don't want uniformly. I want to scale along the z-axis, and I want to scale it 150%. Exaggerate all those fixed features. Check that out. There's no way a 3D printer can handle that, but it also just lets me do what I need to by cutting up. Hopefully it'll be okay. Ooh, no, no, no. A little bit. 0.2. It's not thick enough still. Oh well. So this one's not going to work because this area is too deep. But hopefully this, gets a point across that this is a pretty neat thing that I want to do. Eventually I can make it so it's not using height maps anymore, but rather kind of just noise in general, simplex, Perlin, whatever. So let's go ahead and change the infill a little bit. 20%, yeah, sure, go ahead, just do that. And then we'll go ahead and take a look at the layers, if it can handle that, because there's several hundred thousand vertices in this thing. Let's see if we can do it. Well, we can do it on this tab for sure, at least. Yeah, there we go. Oh man, that's laggy. Preview. Yeah, there. Oh, it might just work. Yeah. There we go. Look at that. There. Reminds me of like a map of the Arizona desert or something, or some sort of mountain. I don't like the layer height. Whatever. I'll make an update video whenever we go ahead and print this on our Anycubic console. But for now, I think this is a pretty neat demo of what's possible using a little bit of creative engineering.